Very good morning to all my dear students. Myself, Dr. Rupak Chakraborty, Assistant Professor, Department of Computer Science Engineering, JNIT Kolkata under JIS Group. So, as promised, my today's topic is pointers in C++. So, we left over yesterday, so that the topic was string in C++. So now we are moving to a very interesting and important portion of C++, that is nothing but the pointers. Pointer is a very important and essential concept which not only which stores the address of the variable. So that is the you already have the idea of pointers when you learned in your previous semester the concept of C language. The same concept can be carried forward when that will help us to learn the concept of pointers in C++. So moving to the contents, what are the things I am going to cover today in today's video lecture. So first of all, how to use a pointer, and also my teaching style. I will show you some hands-on programming as well. So first of all, let me give you some brief idea regarding the pointers and some applications of pointer where we can use this. So that will be shown hands-on, right? So first of all, how to use a pointer. So and how first what is that step? First of all, we should declare the variable, then we have to hold the address of that variable in some another variable. So detailed I will show you. Then references and pointers, then array name, we can pass inside a function array name as pointers. References also like call by value and call by reference concept in the function, we can pass these pointers as well. So some operations on of pointer on arithmetic values. So a pointer arithmetic also I will show you some advanced notations are there. Pointer to pointer, that means the address can be stored into another variable. So that variable should be this would be declared like a pointer to pointer variable. Will show you the example, and last I will finish my lecture after giving some brief idea regarding void and null pointer. These are also required concepts. How to use a pointer? Steps are: the first one is define a pointer variable. How to define a pointer variable? Now, suppose integer I is a variable, then int j is equal to ampersand of I. So j is going to hold the address of variable I, right? So then you have to declare the variable j as a pointer variable. So then it will be int star j. Then it will be int star j. So that is the syntax of declaring a pointer. That is how we can declare a integer pointer here, right? That is how we can declare one integer pointer. Fine. So j is a pointer, is a special variable which is going to address of some another variable. Okay, so I will show you in my. So next one is assigning the address of a variable to a pointer using unary operator and, which returns the address of that variable. Int star j, then we will use int star j is equal to ampersand of I. So here after j we can declare I, and then j will store the address of I. And the last one is accessing the value stored in the address using the unary operator. Now to retrieve the value which has been stored inside I. So to retrieve the value of I, then we have to use the star of j. So star of j, it is known as the value at the address operator. This star is known as the value at the address operator. So in the address, whatever value is there, so it is going to hold the address of one variable. So if I put star j, means out star j, that means whatever it has hold in that, means in that variable. So the value of that variable will be retrieved. This is my next slide. So you can see in C++, the address, the pointer, address of pointer variable ptr. Suppose in star ptr or whatever you may declare in star ptr. So the value of ptr, the value of ptr will be this one. The value of ptr will be this one. It is nothing but a hexadecimal address. It is nothing but a hexadecimal address, and it has some own address as well. PTR is a variable, it is a pointer variable which is going to hold the address of some integer type variable, float type variable, character type variable. So that data type we have to mention at the time of declaring the variable. I will show you the hands-on exercise, I will show you. So PTR is a variable, pointer type of variable that has been declared by int star PTR as unit. So PTR will occupy some address space. So that is the address space of PTR, and PTR is going to hold going to hold one address of another variable, integer type of variable. So that address is the hexadecimal address. See, PTR is equal to ampersand of VAR. PTR is a pointer variable. PTR is equal to ampersand of VAR. Then the value of VAR is 10, and this address and this address is same. So address of VAR has been held by the PTR. Address of VAR has been held by the PTR, and PTR also has some hexadecimal address as well. So that is the concept of pointer. So if we print out star PTR, so that means value at the address, value at this address, value at this address. What is the value at this address? Now that is 10. So that will be displayed. Okay. Now hands-on exercise. Already Ubuntu has been opened up. Nano pointer basic GNU editor has been opened. First of all, we can declare one variable, that is a 20. Now one pointer, we can declare that pointer is going to hold the plus symbol, it is a star symbol. Now PTR will hold the address of this variable, right? Now we can print. Value at PTR equal PTR L. Now copy this line, alt pause symbol, then control U, again control U. Now value at PAR. Okay. Value at start PTR. So start PTR means the variable, means 10 should be the 20 should be the out. So in that case, the output, what will be the output? Now this is the pointer, that means it is going to print some hexa address. It is going to print a variable, that means 20, and it is also going to print 20 because value at the address, this is known as the value at the address operator. This star is known as the value at the address operator. So now control O, control X, A plus plus, enter basic.cpp. Now assembly output. First one is the hexadecimal address. That means this address. Okay, this address pointer is getting some address, holding some address of this variable, and then the variable that is 20, and star ptr means value at the address. Value at the address means in this address what are the value, so that has been printed out. Okay, so now this program, one time you can go through with this program. It's a very simple one. Now next topic. So next topic is references and pointers. So call by value and call by references. So that will be shown references and pointers. So call by value, suppose square one is one function, right, and square one is taking one integer. Square one function has been called from cout, so that means it is going to return some integer value. So that is why the return type has been mentioned as int. N, assume n is an integer, so that is why it has been received by n as well. So it is a call by value. So here we can pass the simple value, and when we will print the address of n outside the function and inside the function, the both addresses will be different because we are passing only value. But here in that example, call by reference, here we are, instead of the value, we are passing the address of n. So outside the function we will print out the address of n, and inside the square two function, see, when we have passed the address, then it is mandatory to receive that address by a pointer variable. So in star n, we have received the address of n by a pointer variable. So inside the function, under the definition of the function, we will also print out the address of n, and we will see the address should be same outside the function as well as the inside the function. Program is required. Program is required. Okay, here I am modifying. Here itself I am modifying. Yeah? So first of all, the logic inside a main I have to write. Let me delete the previous contents. Function. One function I am calling from main. So outside main, it is required to define the function. It should be void because no return time has been mentioned at the time of calling. One integer variable has been defined, that is 10. Now we can address of in one in main. Okay, so that can be copied. We will call one square function from here. Square of in1. square 1 and then we can see no change in N1. So this is the example of call by value. It will be the example of call by value. Let me write the total code, then it will help me to address of N2 in main, then square 2 function we will call square of N2. Square of N2. Now you can see change reflected in N2. Okay. Now we will define the square 1 and square 2 function. Now we have to define the square 1 and square 2 function. Now address of N1, address of N1 in square 1. We are inside the square 1, right? Here we can find now for square it should be N1 star equal to N1, right? Star equal to assignment operator we can use. Assignment operator we can use. Now we have to return this value because the function return type is integer. Fine. So now square 2 we have to define the square 2 function. Square 2 function as address has been passed, that means it is required to use a pointer to receive the address. Now this line can be copied. this has been copied. So this time it should be address of N2. It should be address of N2. It should be square 2, and uh, instead of address you can write N2 because N2 is it is holding one address. Now for accessing the value, it should be this one star N2. Now into equal to, this is the assignment operator, then again star N2, and again it should be star N2. Star N2 means the value at the address, and this is the assignment operator. This is assignment operator and this is the value at the address. So don't be confused. Star N2 means the value at that address operator, and this into equal to is used for. So now what should be the output? So output first of all will be moving to main. Fun gets called. Now inside function n1 0 address of n1 in main. So whatever address of n1 in main means, as we are considering the function as a main function, right? Or instead of main you can write here, if you will, fun. Main means main function actually. Okay, address of n1 in function. If n1 has been, it is a local variable inside a function, so one hexadecimal address one hexadecimal address, it will give address, hexadecimal address of n1. Now we are calling the square one of n1. So square one of n1, so cursor will jump to the definition of the square one. Here we are passing only the value n1. So that value has been received by this n1. So here also we are printing the address of the n1. So these two address I was talking about, these two address should be different. Means the address inside the local function and address outside the local, outside this FUN, and outside the FUN will be different. So different address spaces will be allocated for the n1. Okay. And then the no change in n1, we can see the value of n1 should not change. The value should be same. Okay, the value should be same, but address you can see different. And square of n1, obviously it will be calculated and n1 will be returned. The square of n1 should be 100. So now integer into 10 and function into address we are passing again. That has been received. Here you can see that has been received by a pointer, the address, and now we are printing here the so the into address, whatever the address of into, and here also we are passing the into. So this into, see this into, this into, sorry, this into means address here, the address of into, and here I am writing, right, same address, this one and this one should be the same address, right? This one and this one should be the same address. So that is the beauty of call by reference. And then we have passed this square of into the square pointer has been, it has been received by a pointer. Then the point means value at the address operator has been used, and 10 cross 10, that is 100, and 100 will be printed out over here. Okay, 100 will be printed out over here. Square of n2, that is n2. So this would be the value, that is 100. Change reflected in n2. So change reflected in n2, and means here also the changes you can get that into the 100 should be. That means inside the into operator, whatever the changes, because we are changing directly in the address of into. So So whatever changes, whatever the value, new value has come in that address of N2, so that will be displayed inside the function, as well as the if I print here, if I print here, same value, we will get the 100 as well. Okay, so that is the beauty of this program. That is the beauty of the program. Here the same address, and here we will get the, in both cases, square of N2 it will be 100, and change reflected in N2 it will also be 100, right? Because we are changing in the address. Fine, so that is the program. The output, some error. Okay, so prototype is required. I missed one thing. Function prototype declaration is required. Otherwise, how it can be identified outside the function? I missed it. So prototype should be void function. So void fun one prototype, and then the square int square. It is taking one integer, so that is fine. And the next one is the void square and the stuff. Fine. So this should be the, oh sorry, not square, it is the square one. Nah? It is square one, it is the square two. Fine. So now check it. Now yeah, successfully has compiled. Now address of N1 in function, it is the address of N1, and this address is different. Just see this address and this address is different. The hexadecimal address you can see, and this address is the, it is a different address. So this is different address, but in case of function, I mean square two function, this address and these address are same, because we are passing the address. So outside the function and inside the function, both the cases the address should be same, and as we have changed the value in the address, so that is why we have got the output 100 in both the cases, because we have changed the value in the address, right? So here you can see, here you can see this value and this value is different. Here it is 10 and here it is 100, because we have not changed the value in that address, we have changed the value in this address. So this address and this address is different. So in this address the value is 10, but in this address the value is the 100. But here, as we have passed the address, and in both the cases outside as well as inside the address is same, you can see. So we have changed the, once we have performed the square root of square of the number, and the square of the number is 100, so it has been updated in that, in this address. So when we are printing inside and outside in both the cases, the value has been reflected and we are getting the same value. Fine, clear it is? Or you can once go through the program again. You can again go through the whole program. It's an important one. See, it is the important one. Just go through with this function. It is a very simple and interesting one. Now we will move to my next topic. Array name as pointers. So array name as pointers is, we can pass the array name. We can pass the array name inside a function, and that can be received by a pointer as well. Just go through with the steps. The first of all, an array name contains the address of first element of the array, which acts like constant pointer. So when we are, suppose we have declared int arr is equal to some, that means we have declared with some value. So when we are passing the arr, that means we are passing the base address. Okay, so that means we are passing the base address, and the, so if we so that can be pointed out using the pointer as well. That can be pointed out using the pointer as well. One pointer we can assign to point the base address of the array. One pointer we can assign to point the base address of the array. Then with the help of increment of the pointer, we can access all the values. We can access all the values, right? So it means the address stored in array name can't be changed. For example, if we have an array named val, then val and ampersand of val 0 can be used interchangeably. Either you can write down the name of the array, that is name of the array is val, and val suppose containing three elements, that means val 0, val 1, val 2. So if we are taking the ampersand of val 0, so that means the address of val 0, so the address of val 0 and the name of the array, so both are the same. So that is why one pointer we can assign to hold this address of either this or this. So I will show you the example. Hands on. Hands on is required. Now, nano, so let me declare one array first of three elements. Suppose we are going to assign the value of this array, that is 5, 10, 20. Fine. One pointer, we are declaring one pointer. Now we can write ptr equal to val of 0. Either we can write this, or we may write ptr equal to val. So both are correct. Right? ptr equal to address of val 0, it is correct. ptr equal to val, it is also correct. So I am opting the modern technique. So this is the best one. Now we can print the elements of the array. We can print the elements of the array with the help of this. Elements of the array. How we can print? Yes, we can print the number ptr of 0, ptr of 1. When we can use loop as well. So I will show you next. So like this we can print. So for better understanding, you may add some spaces as well. You may add some spaces as well. So that is how ptr0, ptr1, ptr2. So pointer has become one array now. So ptr0, ptr1, ptr2, like this we can print. So here the output should be 5, 10, and 20, means the elements of the array. Control O, Control X, then use here G++, change the name, ARR underscore enter of element array is 5, 10, and 25. So that is another operation. Now pointer arithmetic, I can show you one pointer arithmetic operation. I can show you one pointer arithmetic operation as well. How we can do the same operation with the help of the pointer arithmetic. So that the topic I have put over here, the pointer arithmetic. There are increment, decrement, and integer can be added to a pointer by plus or plus equal to, minus minus equal to, difference between two pointers p1 minus point 2 p2. So like that we can find out the difference as well. So that I am just showing you in that existing example. Yes, it has been opened up. Now the same problem I am just modifying. A pointer has been received. Pointer is equal to, now one for loop. We can use one for loop. Integer I equals 0, I less than, so three elements, that means I less than 3. Here I can elements of the array. Here I may use ptr and another approach is another approach is value at pointer star ptr. Okay, those two approach has been shown. Now increment the pointer or increment the pointer. So that is how we can display. So first of all, we'll give you the address. First of all, we'll give you the address. Just address of the elements. Address of the elements of the array, because ptr is nothing holding the address, and star ptr, and we are incrementing the pointer here. It is a increment of pointer. Increment of pointer, right? So that is how, using for loop, we can print. So first of all, it will be the address of the first element, then the value at that particular address, then the second element address, then value at that address. So control O, control X, just run this. So you can see, first of all, the address is a hexadecimal address, you can see, and then the hexadecimal address and the value, then the value, address, and value. So this is one example. Now some advanced pointer notation, just go through with this. I will not show you hands on, I am leaving it to the student, so you can do it by your own. Just give me a minute. Okay, so advanced pointer notation, you can see here we have declared one two-dimensional array. So you can when it's a two-dimensional array, that means it's a matrix. So that means we are having two rows and three columns. So it's a zeroth row, that is a 0 1 0 2 0 3. There is a 1 0 1 1 1 2. So now, if we are asked to print the value of this two-dimensional array using the pointer, then how? Then array notation is nums of 0 0. So advanced pointer notation we can use like this, star of nums, then the value will be 16. So that is equivalent to 0 0. Then means here pointer to pointer concept will be, means pointer to pointer concept will be considered. So num 0 of 1, so that is the syntax. Nums plus 2, so we can use the plus operator here. See, this is another, to print out, to display the element of the first row and the first column. What is the element in that first row in first column? First column means second column actually, because it starts from 0. So, or you can see second row, second column, means 1 1 position, means the position is 1 1. To print the element in the 1 1 position of the nums array, so how we are printing as nums plus 1. Nums plus 1 means as it is 0, so 0 plus 1, that means the first row, and then first row, then first column. How we can reach to first column? Then plus 1. So pointer, another, this pointer has been mentioned. So that is how we can, these are the some of the advanced pointer notation. I am leaving it to the students, so you have to try by using this pointer to display all these elements of this two-dimensional array. Now the pointer to pointer concept. In C++, we can create a pointer to pointer that in turn may point to data or other pointer. Here it is a very simple example I have considered, and I think because you are already having, I think, the pointer to pointer notation, because means the address, whatever the address, suppose ptr is holding a var variable, so that address of ptr can be stored by the another variable. So that is the pointer to pointer concept. Here see this one character variable, that is a, character B. Okay, suppose B is holding the address of A. You can see B is holding the address of A. Fine. So now, if we are required to hold the address of B, then character pointer to pointer we have declared, and now C is holding the address of B. So that means B is holding one address and C is holding the address of B. Okay, so I think you can understand the concept of pointer to pointer. Wow. First of all, suppose A is a simple character, assume it is a G. Okay, now A has some address location that has been stored by B. B has some address location that has been stored by C. So if we use here star B, so if we use here star B means value at the address B location. So that means the G will be output. And if we write here star C means value at the address C. So that means the address of B we will get. Now if we print star C, then the G will be the output. Star C means value at the address of B, then again value at the address of, means star C means, but first of all star C, value at the address of C, then value at the address of B. So that is nothing but the G. So that is how I am leaving it also to the students. You can display it. I am not showing it as a hands-on experience. It's a very simple. The concept I have very clearly defined, very clearly stated. Now it is a student task. You can perform it and say what is, how it is giving the output. Now void pointers. So void pointers, the special type of pointer available in C++, which represents absence of type. Okay, so type is not considered here in void pointer. Void pointers are pointers that point to a value that has no type. Okay, so type is not the considerable thing in case of void pointer. They have great flexibility. It can point to any data type. Either it can point to character data type, it can point to integer data type. That then this pointer can be incremented. So everything is possible, cannot be directly dereferenced. It is, as it is not pointing to any particular data type, so that is why it cannot be directly dereferenced. They have to be first transformed into some other pointer type that points to a concrete data type before being dereferenced. So if you want to dereference the void pointer, then it is mandatory to cast the pointer to a particular type, then only it is possible to dereference. Right. So this is the concept of void pointer. Sometimes it may be required to use in your programming to declare a void pointer. Example I will show you later if time permits. Okay, otherwise you can go through in various resources. You can find the concept of void pointer. Just the concept, I think it is required at your level. What do you mean by the void pointer? Just you have to remember this. It doesn't point to any data type. Okay, so that is why it is known as a void. Now another concept is a null pointer. Null pointer is a pointer which point nowhere and not just an invalid address. Following are two methods to assign a pointer as null. See, this is the example of assign a pointer. PTR has been assigned as a null pointer because the value is 0. So either you can put 0 value in the initialization, or you can use the null. So null pointer you may use or you may not. These are not very much important, but the concept, I think it is required. Sometimes it can be required to know the concept, and this type of questions may be asked at the time of interview as well. What is the difference between void and null pointer? So these are the topics. These are the topics whatever I have discussed: void and null pointer concept, pointer to pointer concept, some advanced pointer notation. I am leaving it to the student to find out the output of this two-dimensional array using this pointer notation. Fine. Okay. Some pointer arithmetic concept I told, increment, decrement, like simple variable, like in other variables, the arithmetic means these operations can be done on pointer as well. Array name as pointers, call by value, call by reference. I have already told, call and explained very well with hands-on programming, beauty of call by reference. So address means we can update the value at the same address inside and outside the function, and this is the basic idea of pointer. So that's all for today's lecture for regarding pointer. So in my next lecture I will discuss some basic topics which you already learned in C. So that is structures and unions. So I will discuss the concept of structures and unions in C++. Then I will enter after the completion of structure and union lecture. Then I will enter to the programming object-oriented concept in C++. Okay, so that is the end of today's lecture. I am looking for your kind participation for the next video lecture. So the next video lecture will contain the concept of structure and union with hands-on coding. So that's all for today. Bye bye for now.